picture this for a second. You're sitting in this modern, highly produced studio. The lights are perfectly balanced. The microphones are top of the line. The cameras are rolling.
Right, a totally professional setup.
Exactly.
Yeah.
And then someone walks in and just, places an ordinary, unassuming hat box right on the table in front of you.
Which is already pretty weird.
Right. So you open it up, and inside, resting there, is a real preserved human brain.
Oh, wow.
Yeah, it's wet. It has the consistency of, well, like firm tofu. And her name is Betty.
It really is just this jarring, visceral image to start with.
It totally is.
But I think it perfectly forces us to confront the biological reality of what we're actually dealing with today, because we have this, this pervasive cultural tendency to think of the mind as this abstract, ethereal concept.
Like a cloud of consciousness or something.
Exactly, just floating somewhere above our heads. But holding Betty, it totally shatters that illusion. The mind is a physical structure.
It's actual tissue.
Yes. It is dense, it is wet, and most importantly for our purposes today, it is incredibly malleable.
Her name is Betty. And holding her really forces you to realize that if your mind isn't a cloud, if it's physical tissue, then it can be physically upgraded.
Precisely.
So today, we are taking you on a journey into the literal architecture of that tissue. Our source material is this profound conversation from the Diary of a CEO series.
Right, featuring a fantastic neuroscientist.
Yeah, a professor at New York University who has basically dedicated her entire lab to understanding how we can actively reshape our neural pathways. We're extracting the exact blueprint for building what she delightfully calls a big, fat, fluffy brain.
I love that phrasing, fluffy brain.
It's great. And the stakes here are immediate for you listening. We aren't just talking about, staving off cognitive decline decades down the road.
Right. It's not just about getting old.
No, we are talking about upgrading your mood, your focus, your memory, and your capacity for joy right now, today.
And that's so crucial because we spend an exorbitant amount of cultural energy and, honestly, capital on physical optimization.
Oh, totally.
Like we track macros, we buy expensive skincare serums, we obsess over muscle hypertrophy in the gym.
Kind of get those abs.
Exactly. Yet, we completely neglect the most sophisticated, complex biological structure in the known universe sitting right behind our eyes.
Why do you think that is?
Well, largely because of this persistent, totally outdated scientific dogma that the adult brain is just a finished product.
Okay, let's unpack that historical context because it really sets the stage for everything our source is doing.
We have to.
We used to think the adult brain was essentially a baked clay pot. You put it in the kiln of childhood development, it comes out firm, and from that point on, it's unchanging.
Right, it's just set.
Yeah, and if you drop it, it chips. You lose brain cells as you age, and the only trajectory is just this slow, inevitable decline.
Which sounds incredibly depressing.
It does. But the research completely upends that. The brain isn't a clay pot, it's actually a living city. It constantly builds new rows where the traffic is heaviest and tears down the infrastructure that nobody uses anymore.
That paradigm shift regarding neuroplasticity actually traces back to the late 1960s at UC Berkeley with Marion Diamond.
Oh, right. The rat study.
Exactly. She challenged that baked clay dogma with a brilliantly elegant study. She took adult rats, and the adult specification is crucial here.
Because babies were already known to have changing brains, right?
Right. The scientific community already conceded that developmental infant brains were plastic. The debate was solely about adults. So she placed one cohort of these adult rats into an enriched environment.
The source calls it the Disney World of rat cages.
It really was.
I mean, this wasn't just a slightly bigger box. It was a massive enclosure filled with complex toys that the researchers actively swapped out to ensure constant novelty.
Right, constantly changing the inputs.
And the rats were housed together, facilitating intense social interaction, play, and exploration.
Meanwhile, the control group was placed in standard, unstimulating laboratory cages.
Just a basic shoebox.
Basically, yeah. They had ad libitum access to food and water, maybe one cage mate, but zero environmental complexity. No toys, no novelty, no cognitive demands.
And according to the dogma back then, a rat brain is a rat brain, right?
Exactly. When Diamond examined the neuroanatomy of both cohorts at the end of the trial, there theoretically should have been zero structural difference.
But there was a difference.
A massive one. The Disney World rats literally grew a thicker cortex.
Wait, really? The actual brain got thicker?
Yes. The outer layer of their brains gained mass, the structural changes were profound, the increased cortical thickness wasn't just like swelling.
It wasn't just water weight.
No, it represented a massive proliferation of dendritic branching and synaptic density.
So they grew more connections.
Exactly, because the rats in the enriched environment were processing complex visual, motor, and somatosensory information. Their brains responded by synthesizing new proteins and building more physical infrastructure to handle that processing load.
That is wild.
Diamond proved that environmental demand directly dictates biological supply in the adult brain.
And we see this exact same mechanism scale up to human beings, too, like in that famous London taxi driver study conducted by Eleanor Maguire at University College London.
Oh, that is a classic study.
It's so good. So to become a certified London cabbie, you have to pass this test called the knowledge. You don't just use a GPS.
Right, you can't just follow a screen.
No, you spend roughly 4 years driving around on a moped, memorizing thousands of streets, lawful turns, dead ends, and these hyper-specific routes.
Through one of the most chaotic, non-grid city layouts on the planet. London is a maze.
It totally is. So Maguire recognized this as the ultimate natural experiment in human neuroplasticity. She took a cohort of prospective taxi drivers at day 1 of their training.
Right, getting that baseline data.
Exactly. She ran baseline scans and memory assessments. At that baseline, their neuroanatomy was completely standard. Nothing special.
Okay.
Over the next 4 years, about half of the cohort failed the rigorous exam or dropped out, while the other half successfully passed.
And then she brought them back in.
Yeah, she brought them back for follow-up scans 4 years later, and the contrast was staggering. The dropouts had the exact same brains they started with.
No changes.
No changes. But the successful drivers, the ones who spent 4 years placing an extreme, unrelenting demand on their spatial memory, they showed massive, localized physical growth in the posterior hippocampus.
The hippocampus is our primary engine for declarative memory, but that posterior region specifically handles spatial mapping and navigation.
So they literally grew the map part of their brain.
Yes. Those drivers essentially demanded that their brain house a highly detailed interactive map of London. And the brain, operating as this ruthlessly efficient project manager, recognized the environmental demand.
And just diverted resources to build it.
Exactly. It diverted biological resources to physically expand the posterior hippocampus to accommodate that map.
It's the literal biological reality of use it or lose it. Or, I guess, more accurately, demand it and build it.
Demand it and build it is a much better way to phrase it.
Which immediately begs the question for anyone listening to this deep dive. If the brain is physically moldable, what is the most efficient way to trigger that growth?
Right. How do we hack it?
Exactly. If we want to build that massive, dense, fluffy hippocampus, what is the cognitive equivalent of a heavy deadlift?
To answer that, we actually have to look at a major pivot in our source's own career. She was already an established, highly successful neuroscientist, but she found herself in the crucible of the tenure track at NYU.
Oh, academic pressure is no joke.
It really isn't, and she responded to that immense academic pressure by retreating entirely into her research.
She basically became a machine, right? Designed solely to secure grant funding and publish papers.
Yeah, and she sacrificed a lot for it. She gave up her social life, she stopped moving her body, she barely had friends outside the lab.
Just totally isolated.
Completely. She was entirely sedentary and rapidly approaching a severe burnout.
So she decided she needed an intervention. And she booked a solo river rafting trip to Peru.
A pretty intense intervention.
Right. It was a physically demanding trip, navigating aggressive waters and hiking to Aztec burial sites. And she quickly realized she was the weakest person in the group.
Her physical neglect had completely caught up with her.
It really had. However, the intense daily exertion provided this profound, undeniable boost to her baseline mood and cognitive clarity.
She felt better.
Way better. So returning to New York, she decided she refused to be the weakest person in the room anymore. She committed to a rigorous routine of aerobic exercise.
Just trying to get physically strong.
Yeah, the goal was purely physical strength. But then she experienced a massive unintended consequence.
What?
She tells this story of sitting in her office working on a grant proposal, which in the academic world is a notoriously miserable, agonizing process of competing for limited funds.
Right, it's terrible.
But on this day, she slipped into an effortless flow state. She realized her focus was sharper, her recall for complex literature was faster, and her overall mood while doing this tedious task was wildly elevated.
And as a scientist, she couldn't just enjoy the flow state, right? She had to interrogate the variable.
Of course.
The only significant change in her lifestyle was the introduction of regular aerobic exercise. When she dove into the existing literature on exercise and neurobiology, she found data so compelling that it eventually caused her to reorient the entire focus of her lab.
Wait, really? She changed her whole lab's focus.
Yes, because exercise at a molecular level is the most powerful neuroenhancer we have access to.
The source material actually describes the immediate aftermath of workout as a bubble bath of neurochemicals.
I love that analogy, a bubble bath for the brain.
Right. What's actually in that bath, biologically speaking?
Well, when you engage in aerobic exercise, meaning any sustained activity that elevates your heart rate and forces your body to consume more oxygen, you trigger an immediate cascade of neurotransmitters.
So it's an immediate chemical shift.
Completely immediate. Your brain is flooded with dopamine, serotonin, noradrenaline, and endorphins.
The feel-good stuff.
Exactly. This neurochemical cocktail is the biological mechanism behind the immediate mood elevation, the sharpened reaction times, and that hyper-focused attention you feel walking out of the gym.
Well, that makes so much sense. Like Tony Robbins jumping on a trampoline before a seminar isn't just about psyching himself up.
No, not at all.
He is literally utilizing a biological strategy to flood his prefrontal cortex with dopamine, which directly optimizes his executive function and his ability to command a room.
Exactly. The short-term neurochemical bath is phenomenal for acute performance. But the long-term structural changes, the actual building of a fluffy brain, they rely on a totally different mechanism entirely.
Okay, what's that?
When your muscles contract during aerobic exercise, they release a variety of proteins into the bloodstream. One of the most critical cascades triggered by this physical stress is the release of something called brain-derived neurotrophic factor, or BDNF.
BDNF. I've heard it called essentially miracle grow for the brain.
That is the perfect analogy. BDNF crosses the blood-brain barrier and travels directly to the hippocampus.
And what does it do once it gets there?
When it binds to the receptors there, it does two remarkable things. First, it strengthens existing synapses, making the communication between neurons faster and more efficient.
Like upgrading your internet speed.
Exactly. Second, and more astonishingly, it promotes neurogenesis.
Great, neurogenesis.
Mhm.
We need to highlight how revolutionary that is.
Yeah.
Because the historical dogma said you never get new brain cells.
Right, you only lose them.
But BDNF actively stimulates the birth of brand new neurons in the adult hippocampus.
Yes. The hippocampus is one of the only regions in the human brain where adult neurogenesis has been definitively observed. Every time you elevate your heart rate through exercise, you are triggering a biological cascade that literally births new memory cells.
That's incredible.
You are actively increasing the volume and density of the structure responsible for your life's narrative.
Okay, but the immediate pushback from you listening to this is usually, do I have to become a marathon runner? What if my baseline fitness is literally zero?
It's a very fair question.
But the literature is incredibly encouraging here. Every single drop of sweat counts.
The epidemiological data completely bears that out. Consider this longitudinal walking study that observed adults aged 65 and older.
What did they do?
Researchers simply tracked baseline physical activity, specifically walking, and correlated it with the incidence of dementia over a multi-year period.
And what did they find?
The individuals who simply engaged in a brisk walk 3 times a week demonstrated a 30% reduction in their probability of developing dementia.
3 walks a week. Not triathlons. Just elevating the heart rate slightly above baseline on a consistent schedule.
Exactly. It's so accessible.
And for cognitive upgrades in younger populations, our sources lab actually ran a study with low-fit individuals, like people working out less than 30 minutes a week.
What was the intervention?
They introduced just 2 to 3 45-minute aerobic spin classes per week.
That's really manageable. And the results?
The interventions yielded statistically significant improvements across multiple cognitive domains. Their baseline mood improved, their declarative memory function increased, and their prefrontal cortex efficiency, so their ability to sustain focus and quickly shift attention between tasks, it was measurably enhanced.
That's huge. If exercise is this powerful direct deposit into our cognitive retirement account, we really need to understand the mechanism of protection.
Yeah, how does it actually protect us?
Well, we know Alzheimer's pathology is complex, involving amyloid plaques and tau tangles, and we know exercise doesn't necessarily prevent that pathology from initiating.
So how does a large BDNF-fueled hippocampus protect you from the disease if it doesn't stop it from starting?
This concept is known as cognitive reserve. Alzheimer's disease disproportionately targets and degrades the hippocampus first.
Right, which makes sense.
That degradation of neural tissue is why the earliest clinical manifestation of Alzheimer's is severe memory loss. Like our source's father, tragically getting lost on a drive home from a coffee shop he had visited daily for decades.
Oh, that's heartbreaking. So the disease is essentially a wrecking ball, systematically demolishing the building of your hippocampus.
Exactly. Now, if you enter your later years with a baseline hippocampus, one that hasn't been fortified through exercise, the wrecking ball quickly destroys enough tissue that the building collapses, resulting in severe clinical symptoms.
But if you've been exercising,
If you spend your life engaging in aerobic exercise, constantly flooding the brain with BDNF and birthing new neurons, you build an absolutely massive, highly dense, fluffy hippocampus.
so you've built a 100-room mansion instead of a two-bedroom house.
Exactly the mechanism. The Alzheimer's pathology might still arrive, the wrecking ball still swings, but because you have built such an immense volume of neural tissue, it takes the disease significantly longer to destroy enough of the hippocampus for the clinical symptoms to actually manifest.
Wow.
You are buying yourself years, potentially decades, of high-functioning cognitive life simply by expanding the structural volume of the tissue before the disease ever strikes.
That is such an empowering way to look at it. So aerobic exercise builds the biological hardware.
Mhm.
It gives you the biggest, most resilient hippocampus possible.
Exactly.
But having great hardware doesn't guarantee you are running the right software.
No, it doesn't.
How do we optimize the actual data we store in that tissue? Like if I want to learn a new language, master a presentation, or just remember the names of the people I meet, how do I force my brain to retain that information?
To engineer memory retention, we have to first understand that memory is highly compartmentalized.
Meaning there are different types?
Yes. When we talk about learning a language or memorizing a presentation, we are talking about declarative memory, which is governed by the hippocampus.
Okay, declarative memory.
This is distinct from motor memory, like the physical skill of riding a bike or swinging a golf club, which is processed by the basal ganglia and the striatum.
And it's also distinct from working memory, which the source calls the scratch pad.
Right.
That's the prefrontal cortex holding on to a phone number just long enough for you to dial it, or holding your thought in a meeting while you wait for a colleague to finish their sentence.
Exactly. For declarative memory, the hippocampus relies on specific biological levers to determine whether a piece of information is discarded as irrelevant background noise or encoded into long-term storage.
And she identifies 4 primary pillars of memory stickiness, right?
Yes, 4 primary pillars.
We actually saw the ultimate demonstration of these pillars at the very beginning of the source interview, when the hat box was brought out.
Oh, absolutely.
Bringing Betty the Brain onto the table wasn't just a prop. It was a literal masterclass in hacking the host's hippocampus.
It really was. So let's deconstruct the pillars. The first is repetition. This is the most deeply ingrained method we learn in school.
Rote memorization. Drilling flashcards.
Exactly. The cellular mechanism behind repetition is called long-term potentiation.
How does that work?
When neuron A repeatedly fires and stimulates neuron B, the synaptic connection between them undergoes structural changes to make future communication easier. The more they fire together, the stronger the wire.
Neurons that fire together wire together.
Exactly. It is highly effective, but as a standalone strategy, it is biologically expensive and super time-consuming.
So what's the second pillar?
The second pillar is far more elegant: association. The hippocampus is fundamentally an associative machine. It doesn't store isolated data points, it weaves webs of context.
Oh, like linking a visual face to an auditory name.
Right. Or linking the smell of pine to a specific holiday memory.
Oh, wow. Yeah. Leveraging association is the entire basis of the memory palace technique, right? Or the method of loci.
Exactly. Memory champions who can memorize a randomized deck of cards in under 2 minutes, they aren't using rote repetition.
No, they'd never be fast enough.
Right. They are anchoring highly novel information to a spatial map that is already deeply entrenched in their posterior hippocampus.
Like they mentally walk through their childhood home.
Yes.
If I need to memorize a grocery list, I don't repeat the words milk, bread, eggs over and over. I imagine opening my front door to find a gallon of milk shattered all over the entryway.
That's a great example.
Then I walk into the living room and see a massive loaf of bread sitting on the couch. I walk into
Ah.
the kitchen and the sink is overflowing with eggs.
Right, you are piggybacking new, fragile information onto an incredibly robust, pre-existing neural pathway. When you get to the store, you don't recall the list, you just mentally walk through the house.
Okay, so that's repetition and association. What is the third pillar?
The third pillar is novelty, which triggers an intense evolutionary mechanism. The brain's reticular activating system is constantly scanning the environment, filtering out predictable stimuli to conserve energy.
Like if I walk the same route to work every day, I don't remember the specific cars or the bushes because my brain categorizes them as safe, predictable background noise.
Exactly. From a survival standpoint, predictability is safe. Novelty, however, represents a potential shift in the environment that could be dangerous or, highly advantageous.
So the brain pays attention.
Big time. When you encounter something truly novel, the brain floods the system with dopamine and noradrenaline. It acts as a neural highlighter, signaling to the hippocampus, pay attention and encode this immediately. Our survival might depend on understanding this new variable.
This is exactly why cliches are the enemy of communication.
Oh, absolutely.
If you use a cliche in marketing or storytelling, the listener's brain recognizes the pattern, deems it non-threatening and uninteresting, and literally just stops processing the
Shit
information.
zones out.
But if you introduce a wet, preserved human brain in a hat box during a business interview, that is unprecedented novelty. The brain cannot predict it, so it flags the entire interaction as highly salient.
Spot on. The final pillar is emotional resonance, which relies on the anatomical relationship between the hippocampus and the amygdala.
The amygdala is sitting right there, immediately adjacent to the hippocampus.
Right next door. The amygdala processes emotional valence. So, fear, profound joy, deep sadness. When an event triggers a high state of emotional arousal, the amygdala fires intense signals directly into the neighboring hippocampus.
Like a shock to the system.
Exactly. This chemical jolt dramatically enhances the consolidation of the memory. We remember the days of profound grief and the days of ecstatic joy with high-definition clarity, while the thousands of emotionally neutral Tuesdays completely evaporate from our declarative memory.
If we synthesize those four pillars, the actionable takeaway here is that passive learning is a myth.
A total myth.
If you are reading a textbook or a spreadsheet and just hoping the data sticks, you are fighting your own biology. You have to actively engineer stickiness.
Yes.
Create a bizarre association. Find a way to make the data novel or surprising. Attach a high-stakes emotional narrative to it. You have to give the hippocampus a biological reason to care.
That is beautifully said. However, all of this architectural work, exercising to build tissue and utilizing the pillars of memory, it can be completely negated if your daily behavioral habits are actively destroying your neural networks.
The demolition crew.
We must address the brain saboteurs.
What are we doing every day that shrinks the brain and degrades the hardware?
The primary physiological offenders are well documented at this point. A sedentary lifestyle deprives the brain of BDNF, obviously, but also a diet high in highly processed foods and refined sugars drives systemic inflammation.
And that inflammation doesn't just stay in the gut, does it?
No, it doesn't. The inflammatory cytokines cross the blood-brain barrier, triggering the brain's immune cells, the microglia, to enter a chronic state of activation.
Which sounds bad.
It is, because it can actually lead them to start inadvertently damaging healthy synaptic connections.
Oh, wow. So they attack the brain itself.
In a way, yes. That neuroinflammation is a massive driver of cognitive fog. Conversely, the Mediterranean diet, rich in polyphenols and omega-3 fatty acids, actively suppresses that inflammation and provides the raw materials needed for cellular repair.
Good to know. What else?
Additionally, smoking introduces severe oxidative stress and constricts vascular flow, literally starving the brain of oxygen and nutrients.
The source material also really emphasizes the destructive nature of alcohol, particularly in how it ruins the most critical cognitive maintenance process we have: sleep.
Sleep is non-negotiable.
People often use a drink to wind down because alcohol is a central nervous system depressant. But losing consciousness is not the same thing as sleeping.
It definitely isn't. Alcohol severely fragments the architecture of sleep, particularly suppressing REM and deep, slow-wave sleep. And sleep is not a passive state of rest. It is the most biologically active maintenance period for the brain.
Dr. Suzuki notes that severe, prolonged sleep deprivation is literally fatal.
Yes, the brain simply cannot survive without the two major physiological processes that occur during deep sleep.
What's the first one?
The first process is consolidation. We talked about encoding memories during the day, but the actual firming up of those neural pathways, the transferring of data from short-term holding into long-term cortical storage, that happens primarily while we sleep.
So if you cut your sleep short, you literally interrupt the save process.
Exactly, like pulling the flash drive out before the file finishes transferring.
That's a great way to picture it. And the second process?
The second process is a relatively recent, groundbreaking discovery in neuroscience regarding the glymphatic system.
The glymphatic system.
Yes. Throughout your waking hours, as your neurons metabolize energy to function, they produce biological waste products, specifically proteins like beta amyloid.
Wait, isn't that the exact same stuff that clumps together to form the plaques associated with Alzheimer's disease?
Yes, it is exactly that protein.
Oh, wow.
During wakefulness, this metabolic garbage accumulates in the interstitial spaces between your brain cells. It just builds up.
Like biological exhaust.
Right. But when you enter deep, slow-wave sleep, a profound structural shift occurs. The glial cells, which are the supporting cells of the brain, they actually shrink in size by up to 60%
They shrink. Why?
to open up the pathways. This allows cerebrospinal fluid to rush through the brain tissue, essentially acting as a power washer. It flushes all of that accumulated beta amyloid and metabolic waste out of the brain and into the circulatory system for disposal.
The neurological dishwasher.
Exactly.
So if you only slept 5 hours because you're doom scrolling or binging a show, you are stopping the dishwasher mid-cycle.
And you really are.
You wake up with actual physical metabolic gunk clogging your neural pathways. That feeling of severe brain fog after a bad night of sleep isn't some psychological illusion. It is the physiological reality of a brain swimming in its own toxic waste.
Which brings us to perhaps the most pervasive modern saboteur discussed in the deep dive, the smartphone, and specifically the architecture of social media.
Okay, we need to dissect this carefully, because earlier we established that social isolation is terrible for the brain.
Right, it is.
So the immediate counter-argument you hear from people is, well, I spend 6 hours a day on social media, messaging friends, leaving comments, staying highly connected. Isn't that constant social stimulation healthy for the brain?
It's a logical question, but it misunderstands how the brain works. The human brain evolved over hundreds of thousands of years to interpret social connection through very specific, multisensory physical cues.
Like what?
Like sustained eye contact, the mirroring of body language, the detection of microexpressions, the synchronization of vocal tone, and shared physical space. The brain does not interpret a pixelated notification or a text-based comment as genuine, fulfilling social connection.
So what is the brain actually experiencing during a 6-hour scrolling session?
It is experiencing a highly engineered hijacking of the dopamine reward system. Social media platforms utilize variable ratio reinforcement schedules, which is the exact same psychological architecture as a casino slot machine.
Like pulling the lever.
Exactly. When you pull to refresh your feed, you don't know what you will get. A like, a negative comment, a news alert.
Right.
That unpredictability triggers microspikes of dopamine, creating a compulsive behavioral loop without ever delivering the deep, fulfilling neurochemical satiation of oxytocin and serotonin that actually comes from real human bonding.
So we are overfed on dopamine, but completely starving for true connection.
Perfectly stated.
And the psychological environment of these platforms introduces a massive physiological problem.
Yes, the stress component.
Right. The constant comparison to highly curated, unrealistic lives, coupled with the algorithmic amplification of outrage and tribalism, generates severe psychological stress.
And the brain translates psychological stress into a profound physiological response via the HPA axis. When you feel threatened by a nasty comment or overwhelmed by a news cycle, the brain releases a flood of stress hormones, primarily cortisol.
Now, while cortisol is necessary for acute survival, like running from a predator, chronic elevation of cortisol is incredibly neurotoxic.
Highly toxic. Chronic cortisol exposure literally causes the dendrites in the hippocampus to atrophy.
Wait, it shrinks the hippocampus.
Yes, it impairs neurogenesis. It forces the amygdala into a state of hyperreactivity, making you more susceptible to future stress. The constant engagement with social media is physically wiring the brain for chronic anxiety.
The epidemiological data clearly maps onto this, doesn't it?
Oh, undeniable.
The staggering spike in clinical anxiety, depression, and suicidality, particularly among young girls, it correlates perfectly with the ubiquitous adoption of smartphones and the saturation of social media. We are marinating our brains in stress hormones.
This pervasive environment of chronic stress brings us to a really critical theme in the source material: the modern epidemic of anxiety.
We exist in a constant low-level state of panic.
We do. Yet in her book, Good Anxiety, she advocates for a radical reframing of this emotion. She argues that everyday anxiety is not a pathology or a sign of a broken brain, but rather a perfectly functioning biological warning system.
Okay, to grasp that, we really have to look at the autonomic nervous system. This is the background operating system of the body, controlling our involuntary physiological responses. And it has two main branches.
Right.
The first is the sympathetic nervous system.
The sympathetic branch is our evolutionary fight or flight response. If you encounter a lethal threat in the wild, the sympathetic nervous system instantly triggers an adrenaline and cortisol cascade.
Pumping you up to run or fight.
Right. Your heart rate accelerates to deliver oxygen, your respiration becomes rapid and shallow, your pupils dilate, and blood flow is forcefully shunted away from the digestive and reproductive organs and redirected into the major skeletal muscles.
It is an incredibly efficient system for dealing with a tiger. The design flaw, though, of the modern human brain is that the amygdala cannot distinguish between a physical threat to our biological survival and an abstract psychological threat to our social standing.
That is the core issue. A passive-aggressive email from a superior or a plunging stock portfolio triggers the exact same sympathetic cascade as a physical predator.
Your body thinks you're about to die.
Yes. Your digestion halts, your muscles tense, and your heart races to fight a threat that exists entirely as pixels on a screen. Because these abstract threats are constant, we rarely deactivate the sympathetic state.
So how do we manually override a system that is supposed to be involuntary? Like, we can't just rationally think our way out of a physiological panic attack. Telling someone who is anxious to just calm down is biologically useless.
Absolutely useless. We must activate the second branch of the autonomic nervous system, the parasympathetic nervous system.
The rest and digest pathway.
Exactly. When engaged, it slows the heart rate, lowers blood pressure, and restores blood flow to the digestive tract. It signals to the body that the environment is safe.
And the secret here is that we actually possess a manual control switch that bridges the voluntary and involuntary systems.
We do. The diaphragm.
Conscious, deliberate breath work.
Yes. When you engage in deep, slow diaphragmatic breathing, the physical expansion of the lungs and the movement of the diaphragm stimulate the vagus nerve.
And what does the vagus nerve do?
The vagus nerve is the primary superhighway of the parasympathetic nervous system. It sends a mechanical, indisputable signal directly up to the brainstem. We are breathing slowly and deeply. We would not be doing this if we were running from a predator. Therefore, the threat has passed. We are safe.
It is literally a biological hack to force the brain to stand down.
That's exactly what it is.
It's the reason breath-focused meditation is the foundation of ancient contemplative practices across the globe. Monks didn't have neuroimaging technology, but they empirically understood that manipulating the breath manipulates the autonomic nervous system.
Right. While breathwork manages the acute physiological symptoms, the concept of good anxiety requires us to look at the psychological utility of the emotion as well.
Right, getting the data from it.
Exactly. Difficult, prickly emotions like anxiety, anger, or frustration, they contain critical data. They act as precise compasses pointing toward our deepest core values.
So, if you are overwhelmed with anxiety before stepping onto a stage to give a presentation, that anxiety isn't a malfunction. It is a biological spotlight, highlighting the fact that you deeply value your professional integrity and the respect of your peers.
Beautifully put.
Or if you suffer from chronic people-pleasing anxiety, terrified of letting others down, that anxiety is rooted in a profound valuation of human harmony and social cohesion.
When you reframe anxiety as data rather than disease, it loses much of its paralyzing power. It becomes an investigative tool. What is this discomfort trying to protect? What value is currently feeling threatened?
That reframing works beautifully for everyday stressors, but the source material pushes this concept into vastly more difficult territory.
It does.
How do we extract wisdom from truly devastating dark emotions? Because the host brings up a profoundly tragic period in her life where she lost both her father and her 50-year-old brother to unexpected heart attacks within a 3-month span.
It's unimaginable. She was submerged in an unfathomable depth of grief. And in the midst of this acute trauma, she was tasked with delivering her brother's eulogy.
Which is a terrifying prospect for someone who already possessed a deep fear of public emotional vulnerability.
Right. So she desperately searched for a framework to process this pain. She recalled a phrase from a fitness instructor: "With great pain comes great wisdom."
A profound quote for a fitness class.
Seriously. But she interrogated her own agonizing grief to find the wisdom hidden inside it. And the realization she arrived at fundamentally altered her worldview and basically the premise of her book.
What did she realize?
She recognized that the sheer, crushing magnitude of her grief was a direct, one-to-one reflection of the profound magnitude of the love she held for her father and brother.
Wow. So grief is not a separate emotion from love. It is the exact same emotion, simply experienced under the agonizing condition of absence.
Exactly.
You cannot experience that level of pain without first experiencing a commensurate level of deep, beautiful connection.
When faced with the hypothetical choice of erasing the grief, she realized she would never take that trade, because erasing the grief would require erasing the depth of the love that created it.
The pain was the receipt for a beautiful relationship.
Yes.
The receipt for the relationship.
That realization completely transcends neurobiology. We move past discussions of BDNF and synaptic pruning, and we enter the realm of philosophy and human meaning.
We do. Which leads us to the final and perhaps most vital component of building a resilient mind.
And that is connection. All of the optimization, the exercise, the diet, the sleep hygiene, it is merely the maintenance of a biological vessel. The ultimate purpose of that vessel is connection.
And this is unequivocally supported by data.
Oh, yes. By the longest-running study on human happiness in the history of psychology,
Wow.
the Harvard Study of Adult Development.
Right. For nearly a century, researchers have tracked cohorts of individuals from diverse socioeconomic backgrounds, assessing every imaginable metric of their lives.
And the conclusion is stark and undeniable.
What did they find?
The single greatest predictor of human happiness, physical health, and longevity is not wealth. It is not career success. It is not even baseline cholesterol levels. It is the quality and strength of our social connections.
The human brain is inextricably a social organ.
Completely. The neural architecture of connection is fascinating. When a brain is in the throes of early, passionate, romantic love, the honeymoon phase, the reward circuitry is hyperactivated.
It relies heavily on dopamine.
Yes, creating an almost obsessive, addictive behavioral loop toward the partner.
But as the relationship matures into deep, long-term commitment, the neural activation pattern fundamentally shifts.
It moves away from the frantic dopamine reward centers and relies more heavily on regions associated with empathy, security, and attachment. It mirrors the neural patterns of deep maternal or paternal love.
So the brain transitions from seeking a reward to maintaining a secure, nurturing bond.
Exactly. This profound biological need for connection and meaning facilitated a massive evolution in our source's personal philosophy, too.
How so?
Early in her career, she was a strict, rigid empiricist. If a phenomenon couldn't be quantified in an fMRI machine or measured in a petri dish, she dismissed it.
But then the grief happened.
Right. The intensity of her grief, combined with her deep exploration of the limits of scientific measurement, forced her to soften that rigidity. She recognized that the scientific method is an incredibly powerful tool for understanding the mechanics of reality, but it is insufficient for addressing the meaning of reality.
That makes total sense. She actually found herself returning to the spiritual practices of her youth, incorporating both Christian church community and Buddhist mindfulness into her life.
Not because she abandoned science, though.
No, not at all. But because the ritual, the community architecture, and the engagement with concepts larger than individual biology provided a profound regulatory effect on her nervous system that data alone just could not achieve.
She actually adopted a daily 45-minute tea meditation.
A tea meditation?
Yeah. For years, she had struggled with standard seated meditation. The silence was too loud, the internal chatter too distracting.
I think a lot of us feel that way.
For sure. The tea meditation provided a physical, sensory anchor, the warmth of the cup, the aroma, the precise ritual of the pour. It allowed her to engage the parasympathetic nervous system and sit quietly with her own thoughts without being overwhelmed by them.
We really have a modern phobia of being alone with our own minds, don't we?
Oh, absolutely.
We constantly numb the silence with podcasts, music, and endless scrolling. The source material cites that horrifying study where a significant percentage of participants chose to administer painful electric shocks to themselves rather than sit in an empty room with nothing but their own thoughts for 15 minutes.
I remember that study. It's wild. When we constantly saturate our attention with external inputs, we suppress the brain's default mode network.
What is that?
This is the neural network that becomes highly active when we are daydreaming, reflecting, or simply being still. The default mode network is the engine of imagination.
So it's where creativity happens.
Exactly. It is the space where the hippocampus takes all of your disparate memories and experiences, dismantles them, and recombines them into novel, creative ideas. If you never allow for silence, you are starving your brain of its capacity to synthesize and create.
Wow. So we arrive at the synthesis of this deep dive. Building this big, fat, fluffy brain is a deeply holistic endeavor. You can optimize your macronutrients, plunge into ice baths, and run 10 miles a day. But if you treat your brain purely as a biological machine to be optimized for sheer productivity, you are completely missing the point of the human experience.
The hardware must be maintained so that the software of human connection can run efficiently.
Right.
If we distill the entire blueprint down to its actionable core, it requires 5 distinct commitments from you.
Let's lay them out. Number 1, engage in daily aerobic movement. The intensity matters less than the consistency. Elevate your heart rate. Force the muscles to release the proteins that cross the blood-brain barrier. Flood the hippocampus with BDNF to birth new memory cells and build your cognitive reserve.
Number 2, actively seek out novelty. Do not let your neural pathways calcify into rigid ruts. Challenge the brain with new environments, difficult skills, and surprising ideas to force the associative networks to expand.
Number 3, defend your sleep architecture aggressively. Treat sleep not as an indulgence, but as a critical biological power washing cycle. Give the glymphatic system the time it needs to clear the neurotoxic metabolic waste from your tissue.
Number 4, recognize when your ancient threat detection system is misfiring in the modern world. When the sympathetic nervous system floods you with cortisol over a digital stressor, use the mechanical lever of slow, deep diaphragmatic breathing to force the vagus nerve to engage the parasympathetic rest and digest state.
And finally, number 5, prioritize genuine multisensory human connection over algorithmic engagement. Eye contact, shared physical presence, and community are the foundational nutrients for a resilient, joyful mind.
Every single behavioral choice you make today is actively, physically reshaping the architecture of your neural networks.
You are not a static clay pot. You are the architect of a living city. Every time you choose to take a walk instead of sitting on the couch, every time you choose to sit in silence instead of reaching for your phone, every time you choose to invest in a real-world relationship, you are directing the construction crew to build stronger, wider roads.
I want to leave you with a macro-level thought to mull over, actually. Throughout this deep dive, we have focused entirely on the microenvironment, how your individual habits shape your individual neuroanatomy.
Right, personal choices.
But if human brains are this exquisitely sensitive, this deeply molded by the inputs they receive, we have to question the collective architecture we are currently building.
The societal environment.
Yes, consider the environment we have engineered. Algorithms hyper-optimized to trigger the sympathetic nervous system with outrage and fear.
Yeah, that's true.
City infrastructures that prioritize isolation in vehicles over communal gathering spaces. A relentless 24-hour cycle of digital noise that suppresses the default mode network.
It's a lot when you stack it all up like that.
It is. Are we intentionally designing a society that fosters a healthy, resilient, fluffy collective consciousness? Or are we blindly constructing an environment that forces the entire population into a perpetual, neurologically degraded state of chronic fight or flight?
That is a profound question to consider the next time you find yourself mindlessly reaching for a device.
I think so too.
The ultimate realization here is one of radical responsibility. Everything traces back to that wet, dense tissue sitting in the hat box. Betty.
Everything.
Every fear you have ever felt, every brilliant insight you have ever synthesized, and every person you have ever loved, it all exists within the electrochemical firing of that incredibly adaptable structure. It is the most sophisticated mechanism in the known universe, and its final form is entirely up to you.
Exactly.
Choose your inputs wisely. Until next time, keep diving deep.